In the previous section, we looked at graphing linear inequalities in one variable. Now we're going to move to graphing linear inequalities in two variables. We actually have the tools to do this already. We've used them to graph number lines for solution graphs. Now we're just going to do it in the Cartesian plane. And it actually works fairly the similar way. So let's go ahead and look at the first one. We have y is less than or equal to 3x plus 2. Okay. So here we're given a linear inequality in two variables, but we know how to graph a line in slope-intercept form. Imagine that y is equal to, instead of less than or equal to, if y was equal to 3x plus 2, well, this would be very simple to graph. We'd simply pick out 3 points for x to find 3 points on our line and just connect the dots. Well, here we're going to do much of the same, just an extra step at the end. So let's go ahead and do that. Let's go ahead and pick out 3 points. Remember, we want to pick out some easy values for x. So let's just let x equal 0 and plug it into our slope-intercept form. So we have y. We want to know when y is equal to this value because we want to know a particular point instead of an interval. So we're going to let y equals 3 times x, which is 0, plus 2. That cancels, so we just have y equals 2. And that gives us our first point, 0, 2. All right, let's go ahead and pick out 2 more simple ones. Let's just pick out x equals 1, so y equals 3 times 1, substituting in 1 for x, plus 2. 3 times 1 is 3, plus 2 is 5. So we have our second point, 1, 5. It's just these values right here. X equals 1, when x equals 1, y is equal to 5. Let's pick out one more simple one. Let's get a taste of the negative side. So we have x equals negative 1. So y equals 3 times negative 1 plus 2. 3 times negative 1 is negative 3. Negative 3 and positive 2 gives us negative 1. So we have the third point, minus 1, minus 1. Okay, so now we can go ahead and draw our graph and plot our points. And it doesn't have to be perfect at this point. We can work on the kinks later, but we just want a rough sketch. We have our x-axis and our y-axis. 2, 3, 4, 5. Here's 5. So we have just a couple scales right here. Okay. Now we're going to go ahead and plot these 3 points. 0, 2, which is right here. We have 1, 5, which is way up here. We have minus 1, minus 1. So we have 3 points. All we simply do is connect our dots to draw our line. And once again, I'm not an artist here, so we're going to squint and imagine that this line passes through all 3 points. The line keeps going infinitely in both directions because the range and domain is the set of all real numbers. So we have our line for y equals 3x plus 2. Notice we have a solid line because we're including all the points on the given line. And now when we have an inequality, we know we need a region. We want a region or an interval that satisfies this inequality. So we're going to shade below the line because we want all the values of y that are less than this expression. So we're going to shade below the line. If it was greater than, we'd shade above the line. If it was not equal to, if it was just less than or greater than, this would be a dotted line. Okay, so the rules are pretty much the same as when we're graphing solution graphs on a number line. So let's take a look at another one. Let's make us some room here. All right, next one we have is 4x. We have the linear inequality in two variables. We have 4x minus 2y is greater than 1. All right. We should recognize this as a line given in standard form. So let's go ahead and write this in slope-intercept form by solving for y. So let's go ahead and subtract both sides by 4x. So minus 4x from both sides. That'll give, these two terms will cancel, which gives us minus 2y is greater than minus 4x plus 1. And let's isolate our variable by dividing all 3 terms through by minus 2. These 2 terms cancel, so we have y. Now we're going to have to flip our inequality sign because we're dividing by a negative, so the greater than becomes less than. These 2 negatives cancel. 4 over 2 is the same as 2 times x. 1 divided by minus 2 is just minus 1/2. All right, now here is our linear inequality in slope-intercept form. So let's go ahead and plug in 3 values, keeping them simple, so we can get 3 points on the line. So we have x is equal to 0. That gives us y equals 2 times x, which is 0, minus 1/2. Those two terms cancel, and y is just minus 1/2. So our first point is 0 and minus 1/2. All right, let's pick out a couple more. Let's let x equal 1, so y equals 2 times x, which is 1, minus 1/2. 2 is the same as 4 over 2. It's just converting it into a rational number so we can subtract our rational numbers in the next step. 4 minus 1 is 3 over 2. So our second point is 1 and 3/2. 1 and 3/2. Now I need a third point. So we actually don't really need it. We simply really need 2 points, but just for accuracy and to give us a little taste of what's going on the negative side of x. X equals minus 1, so we have y equals 2 times minus 1, minus 1/2. 2 times minus 1 is minus 2. Let's go ahead and write it in fraction form just like we did above, so we can subtract in the next step. So minus 4 and minus 1 is a minus 5 over 2, giving us our third point, minus 1, minus 5/2. Alright, so now we have 3 points to go ahead and plot on our graph, and we can connect them with a line. Not a whole lot to these. We've done extensively graphing in slope-intercept form in previous sections, and we're just combining that with what we know about graphing linear inequalities on a number line. We're just combining them together to convert it to a Cartesian plane. Alright, so not a whole lot to it. Let's go ahead and graph the point 0, minus 1/2, which is right here. We have 1 and positive 3/2. So that point, and minus 1 and minus 5 over 2, which is right here. Right there. Let's go ahead and connect them with a line. And that line is running through all 3 points. Oh, excuse me. Made a mistake here. Alright, so we just have a less than sign. Now, notice we're graphing this linear inequality, not the one in standard form. Alright, this is one reason why we converted it into slope-intercept form, because it's actually much easier to graph and know where we're shading. But we have a less than sign and not a less than or equal to sign, so we're going to have a dotted line here. Just like when we were graphing on a number line, that means we're excluding all the points on this line, and we just want a particular region. And we want all the values that are less than this particular line, so we're going to shade below. Alright, now recall that we're graphing this line right here, this linear inequality. Standard form, it's a little more difficult to see where we're shading, but notice that it has a greater than sign here, so we might get confused and shade up here. So when we're converting into slope-intercept form, we're going to use this new inequality to graph it and to shade it. All right, and we're using a dotted line because we don't have less than or equal to. We just want all the values that are less than that particular inequality. All right, let's go ahead and look at another one. We have x plus 6y is greater than or equal to minus 3. All right. Now we need to convert this into this inequality from standard form to slope-intercept form. So let's go ahead and do so by isolating y. I'm going to subtract x from both sides. So we have 6y is greater than or equal to minus x minus 3. And we can finish this off by dividing everything through by 6. So we just have y on the left side is greater than or equal to. We can separate this fraction so we can more easily see the slope. So we have minus 1 over 6 times x, and minus 3 over 6 is just minus 1/2. And here's our linear inequality in slope-intercept form. All right, so let's go ahead and pick out 3 simple, very easy to work with values to plug in for x and find our y values so we can plot our points. So we have x equals 0, which means y equals minus 1 over 6 times x, which is 0, minus 1/2. That cancels, so we just have y equals minus 1/2, which gives us the point 0 and minus 1/2. All right, let's go ahead and look at another one. X equals 1, so we have y equals minus 1/6 times 1 minus 1/2. Excuse me. We have minus 1/6 times 1, which is minus 1 over 6, minus 1/2. Let's go ahead and convert this with a denominator of 6. So we have minus 3 over 6. We actually should have left it in this form if we would have recognized that. So let's go ahead and subtract these. So we have minus 4 over 6, or just minus 2/3. That's our second point, 1 minus 2/3. Let's go ahead and find a third one on the negative side. So x equals minus 1. So y equals minus 1 over 6 times minus 1 minus 1/2 equals negative times a negative gives us a positive 1/6 minus 1/2, or just minus 3 over 6. And that gives us 1 minus 3 is a minus 2 over 6, or just a minus 1/3. All right, so we have the third point, minus 1 and minus 1/3. Okay, so let's go ahead and plot these points on our graph, our Cartesian plane. Doesn't have to be pretty. Here's our y-axis. Here's our x-axis. All right, and let's go. This scale is actually going to be fairly zoomed in because the values aren't very big. All right, so we have our first point at 0 and minus 1/2. Our second point is 1 and minus 2/3. It's going to be right there. And minus 1 and minus 1/3. So minus 1 and minus 1/3 is going to be right about there. We're going to go ahead and connect these dots with a line. I apologize for it not being very artistic. The lines go in both directions, and we have a solid line because we have y is greater than or equal to, so that's why we have a solid line, and we want all the values that are above the line, that are greater than y equals, or y is greater than or equal to this expression. So we're going to shade above the line. Now notice we're using the slope-intercept form and not the standard form. We've actually done away with this when we converted it. So it might be confusing when we're talking about greater than or equal to, especially if some point in conversion we flip our sign. All right, so we're just simply looking at the slope-intercept form, shading above, and drawing a solid line because we're including all the points on this line. All right, so we're using what we know about plotting and graphing our linear inequalities on a number line, and we're just putting that on the Cartesian plane, which we already have the tools to do back from graphing in slope-intercept form and such. So we'll do some more of these in the next video. I'll see you soon.